Alright, so we're going to talk about neutralization reactions, which are reactions that occur between an acid and a base. And these are in fact double displacement reactions, which is something that we have done before. And they follow the general pattern AB plus XY makes AY plus XB. So we think of these as compound plus compound reactions. And when we've done them in the past, we've said a metal will switch places with a metal, or a non-metal will switch places with a non-metal. In these examples, we will think of H as being like the metals, even though technically it's a non-metal, but H will form a positive ion, it'll form a +1 ion, kind of like those alkali metals. That's why we showed over on the left-hand side of the periodic table. So basically think of H plus as being like a metal for these examples. So, scenario number one, we've got HCl, hydrochloric acid, and KOH, potassium hydroxide, that's a base. And my products that will form is, what will happen is the H plus will switch places with the K plus. Okay, so the K is going to pair up with chlorine, and the hydrogen is going to pair up with the hydroxide. You will notice that when I make HOH, I've got two H's and an O, so this is, in fact, H2O. And it's okay to write it either way, as HOH or H2O. Whenever you're writing out these compounds, you want to pay attention to charge. So when I put together the K and the Cl, I want to ask myself, what's the charge of these ions? So K is a +1 charge, it's over there in the first column. Cl is a -1 charge. So I don't need any subscripts in this case. I'm fine just writing it as KCl. Same thing with HOH. Think of H as being a +1 ion. It's over there in the first column with sodium and potassium. OH is a polyatomic anion. It is -1 charge. So one H will go with one OH. So I'll always make H2O. Okay. Let's look at the second example here. I've got H3PO4, phosphoric acid, with sodium hydroxide. So, what I'm going to do, follow my pattern, the first elements are going to switch places with each other. So, the sodium is going to go where the hydrogen used to be. They're going to switch places. And the hydrogen is going to go where the sodium is going to be. So, it's going to go with the hydroxide. Notice how I did not transfer my subscript over here. Just because it has a certain subscript on this side, your element will not necessarily have the same subscript on the right-hand side. The way that you figure out subscripts is by looking at charge. Okay, so you look at sodium and say, well, it's a +1 charge. It's over there in the first column. Phosphate is one of those 5 polyatomic ions you need to memorize and know the charge of, and it has a charge of -3. So that means I need 3 sodiums for every one phosphate. So the formula of sodium phosphate is Na3PO4. And then HOH, same as it was up here. This is always going to be the same. This is +1, this is -1. It'll just be HOH. So it doesn't matter if there's 3 hydrogens over here, you're not necessarily going to have 3 hydrogens over here. It's always going to be one H with one OH, and that will make H2O. So every time you put an acid and a base together, you will find that you make H2O as a product. I'm going to go through and erase these charges. And then you will notice that right now my equation is not balanced. I have 3 sodium atoms on the right, only 1 on the left. So you can go and you can make a T-chart if you remember that strategy for balancing out equations. I don't really have room to show that, so I'm just going to add in the coefficients. So I need to have 3 sodiums over here, but now that gives me 3 hydroxides, and I've got 3 hydrogens. So if I put a 3 over here, now I've got 3 hydroxides on each side, 3 hydrogens on each side, 3 sodiums, and 1 phosphate. So now I'm all balanced. Alright, next example is HCl plus magnesium hydroxide. So I'm going to, again, follow the same pattern. My hydrogen is going to switch places with that metal ion over there. So magnesium is going to pair up with chlorine now, and hydrogen is going to pair up with hydroxide. You see a pattern here. And whenever I'm writing the equations for these formulas over here, I have to think about charge. So magnesium is in the second column. It's a +2 charge. Chlorine is way over there on the right. It's 1 away from the noble gases, so it's a -1 charge. So when magnesium and chlorine come together, they're going to form MgCl2. And again, H and OH, H is +1, OH is -1, so it's just going to be HOH. Again, notice it doesn't matter that there's a 2 over here. This subscript does not determine this subscript over here. Whenever you're forming new compounds, you have to consider charge. That's what determines the subscripts. So I'm going to go back and I'm going to erase these charges. I can write HOH as H2O. They're the same thing. And then I have to go through and balance. You notice I have 2 chlorines over here, only 1 on that side. So I'm going to put a 2 right there. And then I've got 2 hydroxides here, so I gotta have 2 over here. So now I'm all balanced. Okay, last example. This one is H3PO4 and MgOH2. So I'll do the same thing. I'm going to switch places. My H and my Mg are going to switch places with each other. So the Mg is going to go with the PO4, and the H is going to go with the OH. I'm going to consider charge. Magnesium is +2. Phosphate is -3. So if I do my crisscross method, the formula would be Mg3PO42, and I have to put a parentheses around the PO4, otherwise it looks like PO42, right? So I'm going to put a parentheses around it. So this is my compound that I form over there. Again, HOH, that's water, that's just going to be HOH. And now I have to go through and balance it. And here is one of those things where you might use a T-chart to count how many of each ion you have on each side. But when you go ahead and balance it, you should find that you need 3 of these, you're going to make 6 of these, and you need 2 of these right here to make this balanced. And as far as terminology, you will notice that what we have is we have an acid plus a base makes a salt plus water. So whenever we do these reactions with an acid base, you will always form H2O as one of your products. And the other compound that you form is what we call a salt. So salt is actually a general category of things that applies to many more things than just our standard table salt, which is sodium chloride. But potassium chloride is a salt, sodium phosphate is a salt, magnesium chloride is a salt. Any of these ionic compounds formed in the neutralization reactions are things that we call salts. So all of these guys over here in this column, they are all, well, draw a circle around them. Those are all what we call salts. Alright, and that is neutralization reactions.